See a red light. Butchy poos in the air, I hope, I think. Hi boys and girls, my name is Butch. My real name is Terry David Silvercloud. You can do a search of me. Today is Sunday, 18th of November here in Vancouver. Sunny day, a little cool. Yesterday I made a video trying to explain unified particle theory, and I spent so much time trying to explain how to wrap your mind around things that I didn't really get to the point I wanted to really make. So today I'm going to try really hard to cut to the chase, and here we go. So I'm 74 years old, and I'm not shy but quite reclusive. I consider the human race to be in deep trouble and so ignorant of so many things that they're a danger to themselves and everyone around them, and I'm just trying to kill time by telling you what I know in hopes it might help save you all. Why, I don't know. I think this earth is... I don't much like this earth. We won't get into that. So today I'm going to cut to the chase and talk about unified particle theory. Now, what are unified particles? Unified particles are anything you want, all doing the same thing with the same purpose at the same time. So if you saw a swarm of bats or a swarm of birds or locusts or whatever, and you can see how they swirl around, they are unified particles. They're all doing... You could think of them as a unit, and they're following rules which are very complex math. If you shoot shotgun pellets out of a gun, that group of shotgun pellets will make a spread, and they are unified particles. They are particles all trying to do something together. Clouds are unified particles. Waves are unified particles. So the issue is, what is the smallest particle? If we live in a universe which is made of particles, and it seems we do, is there such a thing as absolute emptiness? And I say no, so everything we're going to talk about, and I keep diverting because I want to seem to explain every little thing, is what I think. So I want you to think of the universe as full of water everywhere. It doesn't have to be water, but I'm just picking water so that you think of it as there's no empty spaces anywhere. And it's only logical that the universe is infinite everywhere. There is no end. No matter which direction you go, it just goes and goes, and it's full of water. But for the sake of our story, it's going to be a sphere. And spheres are handy because they teach us about infinite stuff. A perfect sphere has an infinite number of pointy parts on it. It's made of so many things that we can't see the flat parts anymore. So the edge of a sphere is an infinite number of pointy parts. So the edge of the universe could be thought of as a sphere, and you are at the center of the universe right now for you. I'm at the center of the universe for me right now, and you aren't even watching this right now, so there's a whole lot of relativity issues going on in there. But for the purposes of this, we're going to think of the universe as being some big sphere, and that teaches us that when we're looking for the very smallest of the small, we don't want to be looking for a sphere, because spheres just have too many pointy parts. We're looking for building blocks that are so small they don't have any pointy parts, but they do because they have to be small. Now it turns out, and the Greeks were on to that tetrahedrons are a good shape. Here is an irregular tetrahedron where all the sides are the same except this side is half what these are. And it's an irregular tetrahedron. And here's one where this was chopped in half and Geez, I don't even know if I can do it. You know, it's half of one of these. So you could conceivably, with enough of these things, start building a torus, as long as you had flexibility on how big these suckers were. So when the Greeks and the Greeks thought you could do a tetrahedra, and mathematicians who are way better than I am say, no, you can't do that. But when you get to irregular tetrahedra, you can do some pretty fancy things. But tetrahedra are limited when they get down to the final plate issue. Then you have to start thinking, oh, the universe is composed of plates. Then it becomes fractal, and it's not really the best solution. And another reason is that when you take any tetrahedron that is not perfectly flat, and even one theoretically that was almost flat, if this is a regular triangle here and you divide each one exactly in half and you're on a tetrahedron, if you chop off all of the pointy parts equally, suddenly you've gone up to a shape that has 8 sides. Like, oops, I thought we were trying to get rid of sides. But the joy of that is it kind of introduces the beginning of what could be a larger shape, and that is the square. So if the basic shape of the universe has to be, and I say it is, things with the least number of pointy parts there are, you can have a perfect regular triangle, or you could have a right angle triangle. And the right angle triangle is really, really, really neat because the diagonal is always the square root of 2, or a multiple of the square root of 2. And there is no limit to how many different sizes you could possibly have then. That's very convenient. So let's get back to the regular tetrahedron, in which we've whacked off 3 equilateral tetrahedra. 4 of them. 1, 2, 3, 4. We've lopped off all the pointy parts. There's 4 of them. Now suddenly we have an object with 8 faces. And by the way, if we lop them off the edges of 2 regular tetrahedra, we would have 6. So it means that there can be I don't want to get into that. Let's get back. I want to get around to the squares first. The thing is, if you take that gets complicated too. You still get down to octahedra. I'm trying to get down to the idea of non-cube type shapes. And we reduced ourselves, we thought, down to a shape, a tetrahedron, which had the least number of faces, the least number of edges. And we thought, oh, hunky-dory, we're there. And suddenly we're faced with a shape which is suddenly becoming spherical again. This is a barrier. Barriers are common. Freezing, melting, sound barriers. They're always associated with numbers. So what we can learn from all this between the tetrahedron and the octahedron is this. We could fill all the space if we just had a bunch of regular tetrahedra and regular octahedra of a slightly different volume. We could fill all of space. That's not very convenient because it seems to reduce reality down to 2 different things. And they are 2 different things, but remember, they're the same things. It was all water. It was all joined anyway. All we're talking about here is a theoretical way of dividing up the volume we already have. And that's the thing. We need to start thinking about infinity like it's full of water, and that anything that takes shape will start to obey the laws of flotation and the laws of buoyancy, and it will start moving, depending on how big it is, towards a place of rest. Big things will bully smaller things. If you start with a universe which was conceivably at absolute rest, full of the oneness everywhere, all at once, all of the time, the only way you could put that together, whether it was a sphere or whether it was a cube, would be a combination of octahedra and tetrahedra. There is no other way. But it doesn't really matter, because those are just mathematical ways of describing of how you could break it up. It doesn't actually have to do that. But if it did, if even one bit somewhere moved, everything else would have to move. It's like when you're in water, if you move your hand through the water has to get out of the way. And the bigger things can push the smaller things out of the way. And do you remember something about the octahedron and the tetrahedron? They aren't the same size. They can't be. It's not possible. They're close, but not quite. So there's a resistance there all the time, and really it's the four tetrahedra pushing against the octahedron at the center. So you could conceive at the center of infinity there is an octahedral shape. A shape which has a square base, not a cube, there's no cubes allowed. Something which has poles, something that can spin left or right. At the center of the universe there is an octahedron, and oops, where is the center of the universe? You are the center of the universe. I am the center of the universe. So the basis of me somewhere in my body at any given moment, because of the laws of motion, there is an octahedral shape doing something. Moving, but it's moving so quickly that it's impossible for us to conceive of how fast it's moving. There are, because of these shapes and combinations of shapes, and because of this bullying, there is just no way that that's why regular tetrahedra a regular tetrahedron cannot fill the universe. You cannot tile them. It is this resistance to tiling of a tetrahedral shape that initiates motion. It's very, very weak. It's as weak as the smallest bully in the universe in which we live. And the smallest bully in which we live is an electron. Now this isn't an electron, but I'm using this for demonstration purposes. So to think of an electron as a sphere, that's okay for all kinds of things, but it's not when it comes to actual reality. Maybe it's fine for waves, maybe it's fine for all kinds of things, but you have to recognize that if it's a sphere, it's got to have a crap load of smaller parts making it up. So I'm telling you, this is my theory. I don't give a crap whether you believe me or not. Excuse me. I smoke so much pot I have chronically runny sinuses. So the basis of our reality is the electron, and I'm going to tell you, you don't have to believe me, that the electron is the first significant shape, and of course I've lost it. I think I would have this stuff out ready. In our reality, and this is the shape of an electron. It's called an icosahedron. Now you'll notice that it has nice even triangle faces, and it does, and there are 20 of them, and it has tons of possible opposite poles, which is all very handy. And you cannot make this from regular tetrahedra, but you can make it from irregular tetrahedra. So I'm going to ask you in your mind to imagine 20 regular tetrahedra that accidentally got themselves into this situation and changed their shape. Remember, there are no real edges. All of these faces are made of something smaller, and I'm going to just tell you it's dark matter. And because everything is trying to become tetrahedral, remember the Earth? Everything is trying to shrink. It's trying to pass out of existence, follow the second law of thermodynamics. Within every cube there are two opposing tetrahedra, and at the center of these opposing tetrahedra is an octahedron. Hope I got that right. Again, there's these different sizes. The very fact that there has to be two different sizes sets up this duality of the universe, which starts from within. Gravity is push, not pull. Gravity is being in the subway and wanting more room. I'm going to tell you, in my world, these irregular tetrahedra have the same volume as a regular tetrahedron if they could get apart. And the reason they can shrink is they're sharing a common support beam. There's actually five edges here, and they just have to be a bit shorter to get these 60 by 60 by 60 degree triangle things to actually join together and not leave any spaces left over. Now in mathematics, this is Johnson solid J13, and it's a pentagonal dipyramid, if I remember right. And it is not 5 regular tetrahedrons, it's 5 irregular tetrahedra sharing a base, as it were, which happens to be a pentagon. Looks like the Chrysler logo. So this shape, I'm going to tell you, in my reality, in my physics, this is an X-ray particle. And there is another possible set of ways of putting those same tetrahedra together with 10 of them, and it looks like this, and it's not a particularly stable thing, but if it has lots of spin, it's very stable. As long as it's got lots of spin, its problem is its poles are recessed, and it really needs help out here to be more pushy. And it can stay together because it's taking the pressures of the universe. Everything's pushing in here and here, but it can be flattened out really easily. But if it got together with 2 of these X-ray particles, these Johnson solid J13s, then you got yourself an electron. Now you got yourself an icosahedron. So I'm going to tell you, in my reality, this shape is a neutrino. And if you took an electron, which would have one of these on this side, and you put a neutrino on either side, you would have a particle called a muon. Muons are extremely unstable, and they're the result of long chains of electrons and neutrinos building quarks. And it would take a combination of quarks can be different size. But quarks are basically lattices of electrons and neutrinos, and possibly some X-ray particles. I'm not a Bucky Fuller. I'm not good at math. I don't like tedious stuff. So am I cutting to the chase today? The basis of our universe is the electron. We are electronic beings. You can't see or hear me, feel me, or touch me without an electron helping move dark energy, dark matter through your brain. And when that dark energy and dark matter passes a spark plug, you got lots of them in your brain registers that, and your brain registers stuff in packets is about 10 per second. You are able to perceive reality in packets of information of approximately 10 per second or less. I say 10 per second because that's what is usually the best average of most human minds. There must be some minds that are processing information at a slower rate, and some top speed athletes may be processing information at 12 or 13 frames per second, and some kids with the right genes might do that, but it wears off as you age. And what that means is your reflexes will be faster because your processor in your brain is running at a higher clock speed than the people around you. So an athlete processing information at 12 frames per second is going to have a significant edge over their opponent processing information at 10 frames or less. So animation is always above 10 frames per second, usually 12. Film is 24 frames per second. Video is not quite 30 frames per second for technical reasons, but almost 30 frames per second. And that's to leave space. Space for the data. You gotta put the data in there somewhere. Sometimes you see the data line across the top of the screen. Where were I? So your brain can only process information because of the size you are, depending on the size of the electron. The electron is what sets the speed of light. The diameter of the electron is the Planck constant, basically. A frequency of 1 would be the electron appearing not to move more than 1 rotation per second. That would be a frequency of 1. If the electron were spinning 100,000 times per second, then it would seem like a frequency of 100,000 cycles per second, and it would be getting pretty agitated by then and really disturbing everything around it. Where were I? 100,000 per second. I wanted to tell you something there and I totally forgot what it was. So information coming into your brain, the electron sets the speed of light. So the electron, I said, only appear to be relatively. How fast it's really turning is all relative because you're moving through the galaxy. For instance, I may think this is turning at one time per second, or I might think it's not turning at all, but if I were turning, then the electron is also turning, a little bit like the moon going around the Earth. So all motion is relative, and the place of most relative rest on this planet is dead center of Earth, and you are standing. When you stand up, the center of the Earth is right down there. You're aimed exactly. That's why you take a plumb bob. When that plumb bob comes still, it's aimed directly at the middle of Earth. Tall buildings are unstable because as the Earth turns, if this is the Earth turning, the top of the building has to travel a whole lot faster to get around than the bottom. So the top of the building already has more inertia. It's already trying to fall down. So a more stable building would be to build buildings that are already pyramidal. Sphere-shaped buildings would be okay, but half buildings are not okay, and you would say, well, why is that? Well, the problem is that the pressure of the universe, remember gravity, I'm telling you, is push, not pull. The pressures of the universe are pushing all around at the bottom and trying to squish the edges of the sphere on the ground out of existence. It took humans quite a long time to figure out how to build a dome, and the secret was to put them on stilts, and the stilts could wiggle and wobble to allow for all the pressures of the dome coming down. And now that I've told you this, if you didn't already know it, whenever you see a dome, you will notice there is always some windows at the bottom of the dome, or else the dome is on stilts. So you need either windows or stilts to keep the dome from collapsing from the pressures of the universe. And that's another reason why spheres aren't the best thing to fight back the pressures of the universe, and why you need tetrahedra. Something I think I forgot to mention, which is really important, is let's go back to the octagon in the center of Yeah, I miss this. This is really important. The octagon in the center of the smallest regular tetrahedron you can imagine. At the center of the universe, there's the very center of the universe, there's this perfect regular tetrahedron, and when you chop off the pointy parts, there's a perfect dual pyramid, like a dual Egyptian pyramid. And what's really important about that is that seemingly roundish object can yet be resolved to tetrahedra. And that's because if you drew a line right down through the pole of the, did I draw, here's an octahedron. If you drew a line from one pole to the other, of the top of the pyramid to the bottom of the pyramid, and then drew out the square plane, right at dead center of that octahedron, you would have 1, 2, 3, 4, and another 1, 2, 3, 4 right-angle tetrahedrons. So ultimately, the universe is tiled right down to tetrahedrons, and the tetrahedra that rule are not regular tetrahedra, but right-angle tetrahedra. And the beauty of all that is, because there could be any infinite number of links, there's an infinite number of these possible triangular shapes possible. Why we don't see more of some in one place than the other all has to do with how big you are. They are all around us. You just don't see them because they're so small. Have I covered everything? I go on and on and on and on and on. Cubes and spheres are large-scale objects, and they're common in our reality because of our physical size. We are so much larger than the bits and pieces of which we are made that we don't notice these differences, but cubes and rectangles and all of the solids, all of the geometric solids that start having faces that get beyond, well, see, you can have all kinds of pyramids, but once you start getting past too many pointy pointings, you're really fracturing the universe. And all this fracturing, it doesn't take much. It only takes a tiny push from one person to do nothing. But if a billion people with that same amount of push all do this push against a wall, say, at the same time, it's going to move. That's the way forces work. So I think I want to shut up. I don't know if I covered it. I'm trying to show you that there are barriers, and I talked about that in the other video, that just occur mathematically, and they're entirely proportional to size. What you think is freezing in the motion levels, the physical motion levels, which we know, and freezing depends on pressure. So it would depend on how big a planet you were on exactly, where freezing might occur, because of, bigger planets can conceivably have, they should have more gravitational forces at the surface, because it will depend on the rotation of the planet, but the inertia on the surface will be larger, and the pressure, these things vary all over the place depending on size, and we are just big enough to be big enough, and light in 1/1000th of a second only goes just less than 1 foot. If this was an atom, you wouldn't know light. The wavelength of light would be so long compared to your size, it would just be a gravitational wave and you would just ride over it. And if you were really small and there was a lot of these waves coming at you like heat waves that just happened to be near your size or your molecule size, you'd be in constant earthquake mode and thinking, I want out of here. And that's, electrons aren't inclined to start really getting excited until they hit wavelengths longer than 680 or so nanometers long. And at that point, photoelectric effects take start happening, and electrons literally start jumping out of their orbits. And once an electron makes a jump, you can turn that, you can amplify that into an electrical circuit. If you just get a few zillion of them to cooperate at the same time, you've got yourself an electrical current. You can capture all that motion. So that's what light cells are about. The certain wavelengths will knock electrons out of their orbits, and if you don't allow them to get back, and you can capture them and save them in a battery, which is what we do. Have I added on enough yet? The electron is what sets our universe. I'm telling you, the electron has the shape of an octahedron, and size has everything to do with everything. That ultimately the smallest of the smallest of the smallest of the smallest shape that can possibly exist is a right-angled tetrahedron. I think I covered it. Maybe I didn't. I probably didn't. Now I'll turn this off and think, oh crap, I meant to talk about that. But you don't have to believe anything I say, but once you start wrapping your mind around the size of the idea that size and time are all relative, and you don't have to worry much about Einstein's relativity. It works for what it's useful for, you know. But when it comes to time speeding up and slowing down, time is a relationship of how fast you can be between here and there at the same time. And if you can be between here and there at less and less time, you will seem to be in the same place at the same time, and you will seem to be stopped. And at that time, solids are happening because there's things happening in here at the speed of light, at a size that's so small that they present to us as a solid. In their world, at their size, they seem to be exceeding the speed of light in relation to an electron, and that's only because the electron sets for us the speed of light. The things that are inside here cannot exceed the speed of light, but for them, in their small size, they are exceeding the speed of light, and they literally fill any given space at a given time. Hope that made sense. It makes sense to me. So don't forget, electrons are icosahedrons. Butch says so. I don't care if you believe me or not. I'm always right. At least I like to be. That's why I'm Butch. Bye from Butch.